Hi, I'm Jeff Applebaum. Welcome to the Cadence Innovation Theater at the 58th Design Automation Conference. In this video, we begin with Vice President Ben Gu on 5G communication IC design and analysis. We conclude by highlighting the use of 3D transient analysis of electromagnetic emissions. And now, here's Ben.
Hello, my name is Ben Gu. I'm the Vice President and the GM for Cadence Design Systems, Multi-Physics Simulation Group. Currently, the deployment of 5G communication system is in full swing around the world, and our entire electronics industry chain is going all out to design and develop high-speed, low latency, and high-density technical equipment that meets the requirements of 5G. In the next few years, 5G will surely change our work and lifestyles at unprecedented speed. At the same time, the design and development of 5G system have brought unprecedented challenges and opportunities to our design methods and tools. Chips, packages, and PCBs and systems are integrated together like never before. High bandwidth, low latency, and low power consumption makes co-simulation of hybrid designs a must. Today, the wave of artificial intelligence is sweeping through the whole world, and the 5G era is also coming. The real world and the internet space are accelerating the integration, and the humans, machines, and Internet of Things are entering a new era of interconnection of all things, and the combination of virtual and real and open sharing. The advent of 5G has fundamentally changed the concept of communication. 5G technology expands the object of communication from people to everything, realizing the interconnect of everything at any time, anywhere, allowing humans to dare to expect to pass information through everything on the earth. 5G, namely, is a fifth-generation mobile communication technology with fiber-like access speed, zero latency experience, connection capacity of hundreds of billions of devices, extra high traffic density, ultra high connection density, and ultra high mobility, etc. A 100-fold increase in energy efficiency and a 100-fold reduction in bit cost. 5G has wealth of applications and trends. Among them, there are three particularly promising trends: enhanced mobile broadband, eMBB, ultra-reliable low-latency communications, URLLC, and massive machine-type communications, MMTC. That's what we often call high-speed, low-latency, and large capacity. Compared with 4G, 5G has achieved a leapfrog from qualitative change to quantitative change, opening a new era of intensive interconnection of everything and deep interconnection between humans and machines, and has become a driving force for a new round of technological innovation and industrial transformation. 5G will inevitably have a revolutionary impact on the neighborhoods where we live and work, including big data analysis, artificial intelligence, and so on. Those major changes will inevitably have a profound impact on our industries, such as automotive, aviation, Internet of Things, medical care, and so on. According to Qualcomm's survey, by 2035, 5G will create $12.3 trillion in economic output. is almost equivalent to the total expenditure of all American consumers in 2016 and exceeds the total consumption expenditure of China, Japan, Germany, and the United Kingdom and France in 2016. By 2035, the global 5G value chain will create $3.5 trillion in output and 22 million jobs at the same time. The above figures exceed the value of entire mobile value chain today. The high performance requirements of 5G will inevitably become the driving force of system innovation, spawning and incubating a series of new design innovations. In order to meet the performance requirements of 5G, radio frequency, and the microwave systems will become exponentially more complex. Those new systems will tightly integrate application processor, baseband chips, and radio frequency chips. And all this will make advanced packaging the most dazzling example of 5G chip design. While we are working hard to deploy 5G technology today, 6G has come quietly. 6G will expand the technological innovation of 5G's high-speed interconnection, ultra-low latency, and interconnection of everything, and further brings us a more extreme user experience. The advent of 6G will push the possibilities brought by 5G technology to another extreme, with faster speeds, shorter delays, and more access devices. According to the current technical plan, 6G will achieve a transmission of speed of 1 terabits with a delay of less than 10 microseconds. Those technical indicators that will now sound like a fantasy will undoubtedly bring unimaginable changes to our lives and to our work. According to the 10-year development rule of one generation, 6G technology should be deployed around 2030, and large-scale commercial applications will be realized around 2035. The revolutionary technological breakthroughs of 5G, 6G have also brought unprecedented challenges and changes to our system design. In order to provide our users with a full range of 5G user experience, our system is far more intelligent and complex than before. Take the 5G mobile phone as an example. We not only need 5G-enabled SoC to deliver data transmission that meets 5G requirements, but also a series of supporting software and hardware such as antenna array, video audio processing, artificial intelligence, machine learning, and so on, to achieve a more colorful user experience. It can be said that 5G-enabled electronic systems are no longer a simple functional system, but a comprehensive intelligent system. At Cadence, we believe that an intelligent system is usually composed of 3 layers. The core of intelligent system is a chip to realize the ultra-high-speed computing data transmission, video audio processing, AI machine learning, and other functions. The processing power of the chip is a core driving force of all the performance in the intelligent system. According to the different system performance requirements, those chips can be SoCs with integrated complex functions, or many functional chips are integrated through advanced packaging or PCB. The layer above the chip in an intelligent system is what we often call the system layer. It includes the hardware system design, a lot of software to deliver a full range of user experience. In the design of 5G mobile phone systems, we usually need to consider technical requirements such as better electromagnetic compatibility, electromagnetic interference, and better heat dissipation. The biggest difference between an intelligent system and a functional system is its uppermost intelligence layer. With the chip and the system, our intelligent system can use the one on the right to generate a huge amount of data. Those data can be transmitted to the cloud for big data analysis, or can also be used at the edge to improve the performance of the system in real time.
So what exciting for me is the fact that first of all we are going to 5G. This means that the bandwidth to the end customer will be greater and bigger, and this is exciting. So the project is basically a remote unit. It's in one end, it interfaces the system via optic, and on the other end, you have an antenna that has to transmit the data in order to repeat the RF signal to the customer. So we have three challenges: high speed, power, and material. High speed, again, we need to make sure that the signal, that we route the signal according to the design and everything work okay, signal integrity. Power, we need to understand to make sure that although the current is very, very high, we still don't have voltage drop. And the last thing is material. Due to the fact that we want to save this PCB cost very, very low, we need to use a very low cost common material. And these security simulation tools help us make sure that all of those criteria will be met. So result from security, I have a live one, good sample. We have a card that do all this process of simulation, pro, concurrent, and post. And I'm happy to say that today in lab we have a card that is working and it's worked great.
For today's data center, designing electronics to analyze the deluge of data presents challenges in throughput, performance, and energy. Minimizing and dissipating heat is a primary design objective. The complex interactions of electrical thermal co-simulation require that components in the system be accurately modeled and analyzed in more detail than ever before. You need a true 3D solution that can scale the entire chip, package, board, and enclosure. Cadence Celsius Thermal Solver offers full system scalability with 3D analysis accuracy, uniquely combining finite element analysis and computational fluid dynamics algorithms, performing steady state and transient analysis, while leveraging cloud computing to maximize throughput. Celsius can import design files from chip, package, board, and enclosure design tools, working seamlessly with production-proven Cadence solutions such as Voltus, Virtuoso, and Allegro to improve designer productivity while creating an optimal thermal design. Cadence, computational software for intelligent system design.